So, for our do now, it tells us to use elimination. Looking at my elimination values, what would be the easiest one to get rid of? The top or bottom equation? Top multiplied by what? 9. So we're going to multiply everything by 9. Distributive property to all these parts is going to give me 45x plus 9y. Negative 14 times 9. What is it? Negative 126. So negative 126 on this. We're going to be able to simplify negative 6x. So I'm just going to rewrite everything so you guys can see it a little bit clearer.
Sorry, yeah.
Yes.
What if I did it backwards?
It's fine. It'll come out to the same thing. Come out to the same thing.
I just wanted to give you a heads up that there's going to be a meeting today.
Sure. Yep.
Just
Yep.
remind
You
you to
got.
stay.
Yeah, guy. You're good.
Okay.
You're good, ladies.
Hey guys.
Always. 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 For.
Third period. I wasn't here today. That's it.
Yep. Yep. Okay. Simplifying this out. So it's okay. So you multiply the top and bottom to get a common value, right, in the reduce down. Is that what you did?
I mean, I did that one with substitution and that one with elimination.
It's okay. Whatever works. Okay. Canceling out my 9y's. It's going to be this. 45 minus 6 is going to give me 39. Negative 126 plus 9 is going to give me negative 117. Dividing both sides by 36, we're going to get x is equal to negative 3. Is this my final solution?
No.
Am I done? No. What should I do? I think the easiest one to plug it back in would be the one up on top. I'm going to get 5 times negative 3 plus y is equal to negative 14. So we want to be able to solve this out by multiplying these two. Negative 15 plus y is equal to negative 14. Y is equal to what? 1. What's my final solution? Bingo. So negative 3, 1, we definitely want to be able to use substitution for these values. Number 2. What do? We have to isolate a variable. We're going to find our isolated variable y and plug it into the one up on top. This will be crucial for that one. We want to be able to solve it in. So negative 5x minus 3 times the quantity. Negative 4x plus 12 is equal to negative 22. And let me rewrite this so we can identify the plug-in value. Again, this is not my regular tablet, so I apologize if it looks bad today. Okay, what should I do from here? Distribute and simplify, right? Negative 5x plus 12x minus 36 is equal to negative 22. CLT, we're going to get 7x minus 36 is equal to negative 22. Adding 36 to both sides, sorry, I just want to get to the new lesson. We're going to get 14. X is going to be equal to 2. Is that what you guys got for the first part? Am I done? No, still not done yet. What equation would be easier to plug it into, the bottom or top? Bottom. Again, could you use the top?
Yes.
Yeah, but the bottom seems a little bit easier. So we're going to plug it into the one down below. Y is going to be equal to negative 4 times 2 plus 12. Y is equal to negative 8 plus 12. Y is equal to 4. My solution? Boom. Good? Questions? Okay, here we go. Pull the hand up. Copy this down. Copy this down. Now, we talked about proofs. We talked about slopes. We talked about being able to write equations, showing that something is parallelogram, showing that something is a trapezoid. Okay, the first parts that we dealt with was using perpendicular and parallel lines. If slopes would be parallel, if the slopes are the same. Perpendicular slopes are opposite reciprocals of each other. So we want to be able to see that. One thing we want to continue and add on to the different types is being able to look at the difference between a rhombus, square, and a rectangle. Isosceles trapezoid. Okay, we're adding everything in now. We're bringing everything together. Okay, now if I give you something, you should be able to prove everything for me and identify how this is. And be able to do that is using our distance and midpoint. We want to be able to use the distance and midpoint to help us determine those values. So that's exactly what we're going to do today. Today is no proofs. Today we're just going to introduce how we're going to solve those out. Tomorrow we're going to look at proofs using triangles, which is essentially looking at sides of them. So we're going to use the distance formula. And then pulling everything together on Thursday, we'll be using quadrilaterals. If I give you 4 points, tell me what type of quadrilateral it is. And by the distance, by the slopes, by the perpendiculars, what can you tell me about it? Okay, and that's what we're going to kind of lead to. The distance d between 2 points and the coordinates of x1, y1, x2, y2 is given by the distance formula. D is equal to the square root of the quantity, x2 minus x1 squared, plus y2 minus y1 squared. So this is the formula. It also derives from the Pythagorean Theorem. If we remember this, a little bit of this from a little bit a while ago, using a triangle. We're going to look at that as well. If you can tell down the next part of your notes, tells us about the Pythagorean Theorem. Now, I'm going to show you the long way of doing it. Some people prefer doing it this way because they think it's easy. Hey, it's easy to me too. I get it. But for visuals and for it to be quicker, I'm going to show you both ways. And I'll show you it both ways. But as we get to the final problems of these, whatever you guys prefer, I'm not going to cry over them. Okay? We always want to tell you, use the thing that makes sense to you, use the thing that is easiest to you. So, you know, if you're taking pre-calc with myself, yeah, you're going to be using the distance formula. If you're going to be taking calculus or being an engineering major, yeah, you better know this formula. So until you get there, as long as you're able to understand how to plug it in, it's very straightforward. Okay. So here we go. The distance between 2 points tells us the length of a segment. In this case that we're going to look at, we're going to be given 2 points. And let's look at writing on here. Let's look at these points as the following. Find the distance between R and S. So R is going to give us the points at 5, 1. So let's go and just graph in R. Kind of draw this one out. R right here. This is R. This is S. So I'm going to go back 3, down 3. And now I'm going to draw those 2 lines in. Now we're basically finding the length of the segment. And it's not as easy as if it was just horizontal and just counting 1, 2, 3, 4, 5. Right? It's not horizontal or vertical. So because we have an angle, we can't just say this is 1, 2, 3, 4, all the way up. Because the lengths of each one of these parts are at a slight slant. So some are bigger, some are smaller. So we've got to be able to use this formula to determine the lengths of this full S to R at a diagonal or at an angle. So we're going to find that out by using the distance formula. This is the hard way, of course. Again, you're going to be able to use it. Now, if you have a calculator, get a calculator. If you have your cell phone out, I'm okay with using your cell phones as long as you're able to use the calculators for them. You'll be required to use those on Friday, so just be aware of that. Okay, so if you want to get one, please get one. Now, the first thing I want to be able to do with this is being able to label our points. I'm going to label this as x1 or y1. And the other one we're going to label as x2 or y2. So if you can identify those, being able to plug these in is going to be super easy for both of these equations. So let's go ahead and just do that. The distance for this is going to be the square root of our quantity, x2, which is -3. So I'm going to plug in -3. Minus x1, which is 5. Minus 5. They're going to square that. Plus our y values, which is negative 3, minus the y1, which is 1. And we're going to square it. So all I did is I took my points and I plugged them in. And that's essentially what we want to be able to do. And now again, don't freak out like I'm scared. This is a lot. This is square roots and squares and terms and adding and subtract. Don't freak out. This is a hard way of doing it. Okay, you should be able to take this and plug it directly into your calculator. You can plug this in directly and give me an answer. But if we want to show all the steps, d would be the square root. What is negative 3 minus 5? Negative 8. Gotta be worried about those negatives. Keep those negatives important. Negative 3 minus 1? Negative 4. So we're going to work inside to out. Square root. What is negative 8 squared? 64. Plus, what is negative 4 squared? 16. Negative, no problem. Let's do the square root, or sorry, what's 64 and 16? So the distance of this is square root of 80. I'm okay with you leaving this as square root of 80. If you want to find the solution to this and simplify it out slightly further, if you take the square root of 80, so let's look at the square root of 80. Square root of 80 will be approximately 8.9. One decimal place is fine with me. So the distance between this is 8.9. From here to here. And that's it. We'll find the lengths of these. For a rhombus, we would find to make sure that all lengths are the same. For isosceles, we'd find only 2 sides. For square, we'd make sure all 4 sides are congruent. So that's what we're going to try to do with a bunch of these. So let's move on. So that's using the distance formula. That's a lot. Okay, let's move on. Let's go ahead and do this one. Pythagorean Theorem. Copy this down in that box right down below. Pythagorean Theorem. Distance formula alternative. Okay, it's the alternate for the distance formula. It's done the same way. Your picture in this little box up here would be represented by the following. The diagonal on this would represent our line. So I'm going to try to draw this out. This would be our line. And that's what we're going to solve out for. It tells us the square of the hypotenuse, or the side opposite to the right angle, equals to the sum of the square of the 2 sides. Okay? If there's anything you remember in high school, it's the Pythagorean Theorem. Right? That's one thing. Ask your parents. They always know. A squared plus b squared equals c squared. Oh, it's another thing where they also know PEMDAS. Please excuse my deer sound. Orders of operations. Okay? This is one of the key things you'll remember. Some of you guys will remember the quadratic equation for some of you. Negative b plus or minus the square root of b squared minus 4ac all over 2a. It's a great one. We'll do that later. Oh, we'll do that later.
English?
Oh yeah, it's a good one. Woo!
Is that English?
Tells you about the factors or the intercepts of a value at your intercepts of a quadratic. Good stuff. We'll get into that. Okay. No, you'll be all right. You'll be all right, man. You'll be all right. Okay. But we'll look at different equations, and one of these ones that we're going to look at is this values. Okay. So here we go. Now, the way that this one is done, I'm going to give you guys work to kind of write down with this, kind of steps, because I think this is an easier way to go about it. Again, just as we did before, let's go ahead and I'm going to give you guys words for this one. So the first thing to say would be to plot points. So let's go ahead and plot our points. I'm going to look at -6, up 5. Is going to be my A, and back 1, down 1 will be my B. Right? I'm okay with that? Let's draw the line between them. And again, we can't just count the squares to make sure the distance is there. Yes?
Negative 1, 1.
Is it negative? Oh, so I'm back up 1. My bad. So we're up 1, right? Back 1, up 1. Sorry, I'm trying to like draw without looking at it. Just seeing if you guys are paying attention, man. Just seeing if you're paying attention. Okay. So we're looking at the distance. We can't just necessarily just count the lengths. Okay. We have to be able to find or use a distance for this. The second thing, the second point for this is be able to make a right triangle. We're going to make a right triangle on this. And what I mean by that is I'm going to convert one of these sides. I usually have my base going down below. Hold on. I usually like to have my base at the bottom of this, so I know I always have a flat piece of surface on this. You can also make it go in the other way. Again, it doesn't make a difference, but it's up to you. Okay, so we're going to make a right triangle out of it. We're making them perpendicular. The third step would be to find the side lengths. Because these are on the side, we can just count the lengths of the side. This is 1, 2, 3, 4. What about the bottom? 1, 2, 3, 4. So we have our lengths, 4 and 5. So we have our lengths 4 and 5. Our next step would be to say, plug into equation. I'm going to abbreviate it because I'm just not spelling right. Now our equation that we want to plug into, a squared plus b squared equals c squared, is very important. We're going to plug into the a and b. So I'm going to plug 4 plus 5 squared is equal to c squared. Does it matter which one is 4 and 5? No, as long as you're plugging into a and b. 4 squared is what? 16. 5 squared? Equal to c squared. 16 and 25?
41.
41 is equal to c squared. How do I solve for c? Square root. Beautiful. I love this. Taking the square root. Okay. We're going to take the square root to both sides. So hold on. I like what you're going with. We're going to leave it as a square root of 41. I'm okay with you leaving it as the answer. If you gave me the decimal, it would be what? What was someone saying? 6.4. Either one would work for me. So the length that we're getting from A to B is square root of 41. This is at length. 6.4 inches. Miss Luna, was she not here? Oh yeah, you are. Here you go. You're leaving. Bye. Doctors. You're going to the doctors. So come and get this for me just so you can take it up to the office. Hope you feel better. Hope you feel better. Or if it's a checkup, I hope you get your checkup. Either or, you're going to be good. I'll give you my last homework until I can print it out. So come and get it. Okay, easy enough, right? Now, do you see why the Pythagorean Theorem is a lot easier to do? It's just easier plugging in. It's easier values you can plug into. So don't worry about that. Let's look at the next one. So let's look at the practice problem. You have 3 rows right underneath you. Here we go. Copy down just a problem. I'm giving you both ways. Some of you guys prefer the Pythagorean Theorem. Some of you guys prefer the distance formula. I'm going to show you both for this one. How many prefer the distance formula? Said no one. Okay, it's fine. I'm okay with that. Okay, if you want to do it that way, I'm going to show you it that way. Okay, but it's really up to you. I'm happy with whichever one you guys prefer. How many of you guys prefer the Pythagorean Theorem? Yeah, I would too. It's easier. But again, I know both ways. Now, step number uno would be to plot the points going over 2 up 3. This is going for A. Over 5 up 7 is going for B. Let's connect them. That's my length I want to solve out for. So that's what I got to find. That's going to be big time. Our value here. Let me change up this color so I can see it. I'm going to be able to create a triangle out of this. Now, do you want me to go up or down? Or just, do you want me to create the triangle this way? Or do you want me to control it this way? That way? Okay, I'll leave it that way. I like making them with the base that way. Sometimes you might want to do it the other way, given the quadrilateral. As long as you're making a triangle out of it, it'll do the same thing. So don't freak out. We're still counting the same lengths. What is that bottom length now? We're trying to solve for that bottom length. What would it be? The top one? 4. Okay, so that's how you're going to do the Pythagorean Theorem on that one. I'll let you guys do that one. For the distance formula, if we want to use a distance formula, it would be x1, y1, x2, y2. I'm going to go and plug this in directly for a lot of you guys. So I'm going to show you guys how I would do it. X2 would be 5 minus 2 squared plus y2 minus y1 squared. Take the square root again. I'm going to get 3 squared plus 4 squared. 9 and 16. 25, right? Is that right?
Yeah.
Your answer was? How many of you guys did the Pythagorean and got the same thing? You should. It's the same thing. Okay, it's done the same exact way. If we do the Pythagorean theorem, a squared plus b squared equal to c squared, using those points that I've just given you, we're going to use 3 squared plus 4 squared, or 4 squared plus 2 squared. I'm going to get 9 plus 16, or 25 is equal to c squared. Taking the square root, we're going to get what? Either way works. Whatever way works. Now, what makes this more difficult is when we do proofs, you're not just doing the distance formula one time. For one proof, you might be doing it 4 times. You might be doing it 3 times. You might be doing it 2 times. So with the distance formula, it's reason why the test is so much shorter. Is because you got to be able to find the slopes of all of them. You got to be able to tell me whether they're perpendicular or parallel. You got to be able to find the lengths of all sides. You got to be able to tell me if they're the same or different. Okay, that's what we're going to get at. That's all proofs is. That's slope and perpendicular and diagonals, and so that's what we're going to get at. So here we go. Let's do one more. Uno más. Here we go. Try this one out. Try it out. Try it out. Try it out. Negative 2, 0. Let me draw this one in. This is C. 6, 4. Eight and 4. Plugging it in. Bless you. Square root of 80. So we got 8.9 for the decimal. Yeah? You guys sound so excited to be here today. So much enthusiasm. You just had a 3-day weekend, man. Be happy. Happy. Here we go. So that, how many people are you good to go? Okay, I can rock those out. Let's do them. Okay, good. Let's move on. So we're going to skip that last problem. We're going to do another set. Skip that. Copy down that. Now, all I want you to do is copy down this and our problem down below. This is just for extra. I'm going to show you guys that right now. Midpoint is also crucial when we deal with diagonals. When we deal with certain parts of our triangle, it's going to come back and look at it. We're going to come and look back at midpoints and stuff like that. Inherent in the name of it, midpoint is the middle point between two lines, or between the line. It's the middle point. And the way that we want to be able to look at this is we're basically taking averages. We're taking the x's and taking the averages. We're taking the y's and taking the average. So we're going to add x1, y1. Or, sorry. x1, x2 divided by 2. Or y1 plus y2 divided by 2. That's it. This one's going to go by a little bit faster. You may have half values. You may have decimals in here. It is completely acceptable if you do that. Okay, you can definitely have that. So don't freak out. Don't freak out, man. Don't freak out. Okay, but you can have that. You can definitely have that. So we're going to kind of look at this without graphing it first, and I'm going to show you guys how we're going to graph that together. It is definitely acceptable. If you have my calculators at all, some of them might convert them into decimals already instead of fractions. But if you need to separate that, the button above the orange calculators, above the delete sign, you're going to see a line that says SD. S to D or D to S. In that case, it means standard, meaning leaving it as a fraction, to decimal, which is changing it to decimal, and vice versa. It'll convert both of those for you guys. Our first one here. Let's jump into it. First thing we want to be able to do is label our points. X1, Y1, X2, Y2. And essentially what we're going to do is we're going to take that value and we're going to plug everything in. So I'm going to do, the way we write our midpoint is mid PT, or midpoint, is equal to, and we're going to just plug it into that big equation. We're just going to plug it in. X1 is -1. So we're going to do -1. X2 is 6, so plus 6. And we're going to divide that by 2. Straightforward. We're going to take our Y1 is 2. Make it a little bit thicker. So we're going to do Y2 plus Y1 divided by 2. All we want to be able to do now is simplify. What's -6 plus 6? -1 plus 6. Look. 5. So 5 divided by 2. What's 2 plus 1? 3. You said 2? Don't say 2. Okay. Now that was an acceptable answer, but we got to be able to plot it eventually. So if you give me decimals, what's half of 5?
2.55.
Half of 3.
1.5.
This would be our answers. So I'm looking for these two. And that's it. Okay, we're going to put more context to it when we graph it, but this is just the beginning of it. So we're going to be able to find that. Again, take your values, 5 divided by 2, boom. 5 halves. So if you change it to decimal, it'll give you 2.5. Okay. Here we go. Let's look at our practice. This is kind of straightforward. So again, I'm giving you the midpoint. I will give you the formulas. I will give you the formulas to use. I'm not going to tell you how to use them, but you guys should know how to use them. But I will give you them because the distance formula, Pythagorean theorem can be confusing. You guys got to remember the properties. I might give you guys an index card for you guys to use. Index, right? What do you need to show for a parallelogram? What do you need to show for a rhombus? Ooh, that might be interesting. I'll find out. For the first one, let's plot our points. The first point would be back -4 up 3. This is going to be T. negative 1 up 5. This is going to be S. Now the point between these, so we're still going to draw the line between them. So let's do that. Okay, one thing that I want you guys to know is when we find the midpoint, it has to exist on this line. It's the middle value between you. So I'm guessing it's here. I'm guessing it's that point. We can guesstimate where it's going to be at. But if I get a value when I solve it out and I get 1, 1, am I right? No. It's not even the midpoint of that. It's not even on the line. So we know we have to be negative and positive on here. So that's what we got to be able to see. So let's go ahead and do it. Let's go ahead and do this one. X1, Y1, X2, Y2. Y1, X2, Y2. So let's take it to the next level. Let's go ahead and plot these in. Midpoint will be my values. Negative 4 and negative 1 will be added together. Negative 4 plus negative 1 divided by 2. Then we're going to take our 3 and 5. We're going to add them and divide by 2. So let's see what happens. Negative 4 plus negative 1. Negative 5. So we're going to get negative 5 over 2. And then 3 and 5. 8 divided by 2. Okay, good. So we're going to get this final solution of negative 2.5 and 4. This is considered our midpoint. Both of these are technically. Okay, if I plot that point, again we have halves for this one, so be wary. I'm going to go back 2.5 and up to 4. Look at that. Look at that beauty. This is the midpoint. I want to be able to label that. Middle point. Midpoint. Yes?
So the fractions and the decimals are both part of, like, they're both part of your answer?
They're both the same. They're both the same. If I'm just asking you for the midpoint, you can give me the fraction for it. If I'm asking you to give me the midpoint and graph it, what would be easier to graph would be the decimal than that, right? So either one works for me. Depends on what I ask you. But as long as if you could see them both through it, again, you have the calculators to use, so use them. Use them. Cool beans? How are we doing? Try this next one, we're done. Try this next one, we're done. Here we go. Last one here and then homework time. Here you go. Catch it ahead. Catch it ahead. Let's check this out. I want to be able to see what I'm going to be writing. So I'm going to go and plot my points back 5 down to C over 3 up 5 is D. I'm going to connect my points. Now, just by looking at here, just by looking at this, I know it has to exist on my line. So I'm going to guess, did you guys get negative 1, negative 1, 1.5?
Yeah.
Yes.
Boom. We're genius. Okay, but it's pretty simple. It's pretty simple stuff. We're all just taking the halves and halves of these, right? So here we go. If I want to find that out mathematically, okay.
I know, same.
You got too lazy?
Yeah, I just count them and be like, close enough.
Midpoint will be negative 5 plus 3 divided by 2. You should have got negative 2 plus 5 divided by 2. Take your x's and add them. Take your y's and add them. We're going to get negative 2 over 2 and 3 over 2. Which if we were to reduce this would give me negative 1, 1.5. So each one of these are going to be crucial to our solution. Cool beans? You guys good? Yeah. That's all she wrote. There it is. You guys have your homework. Go ahead and complete that.